Hello class, and today is your first set of notes that you're going to be preparing and taking before class actually starts. Now what we're going to learn about today is the scientific method, and there's really 5 objectives that we're trying to accomplish here, and we'll go over them one at a time. The first one is what actually is science. Now science is really a way of gaining evidence, which is basically a way of saying gaining facts about the natural world around us. Everything that science does tries to explain the natural world, meaning that we do not cover anything that is unnatural. So only the natural things, the things that are physical, living, maybe non-living things like rocks, the things that you can actually, appear before you. That constitutes the natural world. That's what we're going to do, and it's a better understanding of it. Now, what do we do in science? There's kind of 3 things that we do in science. We help explain our world around us. We help predict what is to come, so kind of the future looking at, and it also is used to make our lives better. The great advancements in medicines and kind of things going on in the future here. Technology, that's a huge part of science. It is all done to help prepare us for, to better our lives and how we currently live. Now there's different types of sciences. In this class we're going to mainly do biology and earth science. Next year you're going to look at the other 2 big major topics of science, which is chemistry and physics. So combined, all those kind of wrap up into some way, shape, or form into the different sciences. And that's kind of what science is, the background of science. In the second part here, we're going to look at the different steps of the scientific method. Now, what the scientific method is, it's a series of these steps, and I use these quotation marks because they're not tried and true steps. Different scientists will use different parts of them depending on what they're doing, what they're experimenting with. It's a general guideline, though, of how a scientist thinks and how a scientist acts. This is not the case 100% of the time. In fact, most scientists nowadays have some kind of altered version depending on what they're most comfortable with. But it's all done to try to answer an event, to answer a question based off an event that has occurred. And there's a couple of different steps that go along with it. The very first thing that you typically do is something that just comes natural. It's what's called observation. And it's noticing and describing things in a very careful way. So there's different things that you can do to observe things. It's using your eyes, sight, taste, smell, hearing. Those are all your powers of observations. It's using your senses to get a hold of what's happening around you. The second step kind of goes along with the first step. It's what's called inference. I-N-F-E-R-E-N-C-E. And it's your interpretation of what's going on. What do you know? It's all your prior knowledge that you come in with. A lot of you guys come to class with a lot of experience and with a lot of knowledge about what is happening in the world because you live in it. It makes sense. So inferences is using that knowledge to try to make sense out of the situation. The next step is actually getting into the experimental procedure. It's the hypothesis. Now you may have heard before that it's called an educated guess. I hate that way of thinking. It's not a guess. It's a testable prediction. And basically what it is that it's something that you can actually test. A guess, you could guess anything. But a prediction is something that you think is going to happen. And that's what a hypothesis is. It's what you think is going to happen. And it's something that we can go through and test later on. The next part is the experiment. That is where we actually start getting the experiment done. It's where you start, you create a procedure, which is a series of steps that you follow, and it's all done to try to test your hypothesis. We then get our data. Those are any of the records or observations that you make during the experiment. Typically, it may involve measurements, and you probably will be creating a graph or a table of some kind to show your data, put it all in a nice organized fashion. That's why we've been spending so much time learning about the metric system and for graphs, is because it's the primary use of how we get data. It's the evidence we get from the experiment. And then finally is our analysis and conclusion sections. This is where the evidence from the experiment is used to either support your hypothesis, deny your hypothesis, or you may just decide to revise everything altogether and try again. Basically, it's taking what you did in the experiment and reflecting back on it and seeing what you accomplished during it. The third section that we're going to be looking at is how to correctly write a hypothesis. Now, not all scientists are going to use this exact fashion, but this is going to give you a basis for how you should be generating your own hypotheses. The format that we're going to use is that we're going to state our problem in the beginning and then give our prediction at the end. And there's two sections that we'll do this by. We start off with the word if. If I do this, that states your problem. You add a comma. Then I predict this will happen. So now you're predicting what's going to happen in your experiment. So here's an example of how we can use that. If watching television causes poor eyesight. Right there's our problem. We have if watching television causes poor eyesight. So our problem is that TV causes our eyesight to go bad. That's our problem. Well, what's our prediction? This is where the second part comes into play. Then I predict the less television you watch, the better your eyesight will be. There's our clear prediction of what the outcome is going to be. So once again, all of it all together, from beginning to end. If watching television causes poor eyesight, then I predict the less television you watch, the better your eyesight will be. Your entire experiment is summed up in one sentence, and that really is what your hypothesis should be. It should tell you your problem and what your prediction is about your experiment. Because remember, a hypothesis is going to be a testable prediction. Our fourth section that we're going to look at is all the different parts that are a part of the experiment. Now, when you do an experiment, typically you're going to have what's called a control group and an experimental group. Because in order to see if your results actually showed something, you need something to compare it back to. What the control group is that this is the normal group where we are just testing the experiment without anything affecting it. There's nothing thrown into there, there's nothing changed about it. This is what you would normally expect something to happen. So it's considered your normal group, your control group. Everything is controlled. There's no variables affecting your situation here. We then have the experimental group. The experimental group is where you add one new thing to the entire experiment that changes it up. And for a good experiment to occur, you can only change one thing at a time. Otherwise, you may not know what thing is affecting it. It could be the thing that you changed we'll call A, or it could be the thing that you changed which we'll call B. If a change happens, you don't know really if A caused it or if B caused it. But if you only did A, and A was the one that changed something, then you know for certain that A had an effect on the experiment. So the control group is your normal comparison group. Your experimental group is the addition of the one thing that you're wanting to change. Now, I mentioned a word in there called a variable. The variable is something that can change in an experiment, and you have control over these variables. Typically, you change only one variable in the entire process. There are two variables that we'll take a look at. One of them is based off of our data that we're going to collect. The other one is the thing that we actually change. The first one that we're going to look at is what's called an independent variable. This is the one thing in the experiment that is going to change from the control group to the experimental group. So what is the one thing that changed from experiment A to experiment B? That is your independent variable. The one thing. You know, I looks like a 1. It's the one thing. It's independent. It's what separates out one thing from another. Your independent variable. We then have what's called our dependent variable. This is the part of the experiment where you are actually getting the data off of, and it's your measurements that you're getting. So let's say we are measuring how long a race car travels when you apply different forces to it. The distance that it travels is going to be your dependent variable, because you don't know really how far that car is going to travel. That's the thing that you're going to measure. You can decide on how hard you're going to push it. That would be your independent variable. You know, maybe you push it hard. Maybe you give it a nice soft push. That's the thing that you are changing between your control experiment and your experimental group, a part of the experiment. Anything that does not change from the control group to the experimental group is what is called your constants. And these are the things that remain the same no matter what. They stay constant throughout the entire experiment. The last section that we're going to take a look at here is the differences between different ideas that scientists generate. There are a couple of different words that scientists use in order to explain their ideas. There's what's called laws, theories, hypothesis, opinions, and facts. We're going to look at laws first. Laws are a phenomenon which are always true. So no matter what, it's always going to be happening. An example of that is the law of gravity. The law of gravity says that there's gravity on Earth that is constantly acting upon us. And that is the case. If you go to a different planet, the gravity changes because the planet size is different. Theories, on the other hand, is a well-tested explanation that brings together a broad range of observations. So a theory is something that is very tested. It has been tested year after year by multiple scientists. They've always got similar results. It covers a broad topic. It's not specific like a law. It's very broad. It covers a lot of information in there. Our hypothesis, it's just our testable predictions. Anybody can make them as long as it's testable, and as long as you're doing a prediction, that's an hypothesis. We have opinions. Opinions are personal beliefs based off of your interpretation of the facts. Opinions are not facts. Opinions are what you believe. There may not be evidence to support it. It's what you think is going to happen. It's what you feel is going to happen. It's your personal beliefs. It's not rooted in evidence. Facts, however, is a truth known by actually experiencing it or an observation happening in nature. It's something that has evidence behind it. So the opinion versus the fact. Opinion is something that's personal to you. A fact is something that has evidence behind it between them. And that covers our differences between laws, theories, hypotheses, opinions, and facts. And that ends our final version and final part of these notes. So make sure that you have these prepared for Monday. And hopefully you're all ready to go by then. Take care.